Today we're going to be learning about finding cubes. Now I know it may sound easy, but it actually requires a bit of logic and imagination. So let's get into it. How many cubes are there in each of the figures shown below? A. For these we're going to separate it into layers, multiply the number of cubes in each layer, and then add all of those together to find the total number of cubes for each figure. Let's begin. The first layer is going to be 3 times 3, which is 9. The second layer is going to be 3 times 2, which is 6. And these top two layers are going to be 3 times 1, which is 3. So you add all those together, 9 plus 6 plus 3 plus 3, to get 21 cubes for A. B. Same thing for the bottom layer. It's going to be 2 times 3, which is 6. But for this top layer, we can use logic and see that it has 5 cubes since it's only missing 1 cube from the bottom layer, which had 6. And then this third layer is going to be 5 minus 1, 2, which is 3, and this top layer is 1, as you can see. So add all those together, 6 plus 5 plus 3 plus 1, to get 15 cubes for B. C is going to be 3 times 3, which is 9, times 3, which is 27 cubes. And we can use this for D and just subtract the ones missing in D. So it's going to be 27 minus 3, which is 24, minus 2, which is 22 cubes for D. Same methods for these problems. A. 3 times 3 is 9, plus this layer is 9 minus 1, so it's 8. And these two layers are 8 minus 2, which is 5. Add all those and you get 27 cubes. B. 3 times 4 is 12, plus 12 minus 1, 2, 3, so that's 9. Plus 9 minus 1, 2, which is 7, plus 1, 2, 3 in this layer. Add all those and you get 31 cubes. C. 4 times 4 is 16, plus 3 times 3 is 9, plus 2 times 2 is 4, plus 1. That equals 30. D is a bit harder since there's a hollowed out part, so we're just going to multiply and find the total number of cubes that would be in D if it was full, and then subtract the hollowed out parts. So it's going to be 5 times 3, which is 15, times 3, which is 45 cubes, minus 2 times 3, which is 6 hollowed out cubes, and that gives 39 cubes. Again, same methods here. This one has a hollowed out middle, so instead of there being 9 cubes on this side, it's going to be 8 cubes. So we're going to take 8 and multiply it by 4 to get 32 cubes. B. 3 times 4 is 12, and the second layer is going to be 12 minus 2, which is 10. And the third layer is going to be 10 minus 1, 2, 3, 4, 5, so that's 5. And the fourth layer is going to be 1, 2, 3. Add all those together and you get 30 cubes. C. It's going to be 3 plus 5 plus 7 plus 9, since you add 2 to each layer as you go down. That's going to be 24 cubes for C. Now these problems are going to require a bit more imagination, so let's start. 27 identical cubes are used to form the cuboid shown below. 6 faces of the cuboid are then painted in yellow. Complete the table below to show the number of cubes with different numbers of faces painted yellow. First, let's visualize the cuboid painted yellow. Awesome, there we go. Now, there will be some cubes not painted yellow at all, such as the one in the very middle that's not exposed on any sides at all. And then there's going to be some that will be painted only on one side, such as this one in the middle of each side. And then there will be some that are painted on 2 sides, such as these 4 on this side. And then the corners are painted on 3 sides. So let's use that information and let's fill out this table. So we just figured out that there's only 1 cube in the very middle with 0 sides painted yellow. And then there's going to be 6 sides with 1 side painted yellow because the one in the middle of each side, and there's 6 sides of this cube, so that's 6. And then there's going to be 12 with 2 sides painted because you have 4 on this side, 4 on that side, and the extra 1, 2, 3, 4 that weren't covered, so that's 12. Then you have 8 cubes with 3 sides painted yellow because you have the 4 corners on this side and the 4 corners on that side. And then there can't be any cubes with 4, 5, or 6 sides painted since all of these are tight together and touching, and since none of them are separated. And then you add all these together and find the 27 cubes that the problem mentions. Let's do the next one. The eye-shaped object below is made up of 9 identical cubes. The surface of the object is painted blue. After the paint dries, the cubes are separated. Complete the table below to show the number of cubes with different numbers of faces painted blue. So, I don't have a picture for this one, but that's okay, we can still do it. And also, for simplicity reasons, we're just going to keep imagining the image as this, because even though the problem says that the cubes are separated after the paint dries, that's kind of irrelevant because even if the cubes are separated, they won't get like add sides that are painted, so it doesn't really matter. So let's begin filling out the table. So you can't have any cubes that have 0 sides painted since this is a 1D object, and so all the cubes have at least 2 sides or 3 sides exposed. So you also can't have cubes with 1 or 2 sides only painted because that's just too little. So then you have 2 sides or 2 cubes with 3 sides painted yellow. And that's going to be this cube and this cube because it's going to be the top, the side, and the bottom. Then you're going to have 3 cubes with 4 sides painted yellow or painted blue, and it's going to be the top, the side, the other side, and the bottom. And then you're going to have 4 cubes, these 4 corners, 1, 2, 3, 4, that have 5 sides painted, as you can see, 1, 2, 3, the bottom, and the other side. And then again, you can have any cubes with 6 sides painted blue because these are all connected and you don't have any lone cubes. So we add all those together and that gives us 9 cubes in the problem, so we're good. Alright, this is the last one. The figure shown below is made up of 12 identical cubes. It is then painted green before all the cubes are separated. Complete the table below to show the number of cubes with different numbers of faces painted green. I don't have an image for this one. And also we're going to still imagine it like this and not separated like the last problem too because it doesn't matter. Separation doesn't increase or decrease the number of sides painted. So let's fill out the table. Again, you can't have any cubes with 0 sides painted since this is 1D. And you can't have any with only 1 side painted since, again, it's 1D. But we're going to have 2 cubes, this one and this one, with 2 sides painted green since they're enclosed on all other sides, so they only have their top and their bottom painted. There's also going to be 2 cubes with 3 sides painted green, this cube and this cube, since they have the top, this side, that side, and the bottom. Then there's going to be 6 cubes with 4 sides painted green, which are going to be these 2, and this one, and this one. As you can see, it's the top, the side, this side, and the bottom. Then you're going to have this cube and this cube, so 2 cubes painted with 5 sides green. As you can see, it's the top, the side, the other side, this side, and the bottom. And again, you can have any cubes with 6 sides painted green because these are all connected and none of them are lone. So we add these all together to get the 12 cubes mentioned in our problem, so we're great. Alright, so that's it for this video. I hope it helped and have a great day.